Hello everyone, it's Benny, and today we're going to be continuing development of the 2D role-playing game that we started in the last video. So what we've done so far is we have set up a basic game engine. It's not quite finished yet, hopefully we'll finish it in this video. And all we've really done is we've set up the management system, we've set up the game object, and we also implemented this nice animation system. So what I'm hoping to do in this video is finish the GameObject class, because there's still a few things we need to do. I'm hoping to implement the physics system, which seems like it would be really complicated, but it's actually going to be incredibly simple. And hopefully we'll get a player showing up on the screen and running around, and maybe we'll even implement leveling. I don't know. We'll see how much time we have. So with that out of the way, let's get started. First off, let's finish the GameObject class, because we never quite finished it, and I think it's pretty good to just go ahead and finish that before we do anything else. So, the first thing we need to do in finishing the GameObject is we need to get rid of this animation that it has. And that might seem a little bit weird, because we spent a lot of the last video creating this animation system, but the reason I'm getting rid of it is because we're still in phase 2 of the development. We don't want to have any fancy graphic effects, and really the only graphic effects we need is just something that allows us to distinguish between different objects. So we don't need animation. And frankly, it's a little bit complicated, and I don't want to risk there being a bug in there and that screwing things up. I want just the bare minimum to get a game that works. And from there, we'll sort of create whatever graphics and whatever we want to go along with that, and that will include putting in the animation. But for now, I'm going to get rid of it. So I'll just erase it and instead have a sprite. So, now that we've gotten rid of the animation system, the next thing that I want to do is I want to implement the render method, because all of our game objects will generally have the same rendering system. Some of them might differ a little bit, but most of them are going to be exactly the same. So, what I'm going to do is I'm just going to go ahead and create the render method. So first I need to import OpenGL. So I'm going to import static org.lwjgl.opengl.gl11.star. Not AMD blend effects factor. I'm not quite sure what that is. But there, we now have imported all the OpenGL methods, and all we really need to do here is we need to render the sprite, so spr.render, and that will draw whatever sprite we have. We will need to adjust for our position, so I'll do gl translate f, x, y, and nothing in z, because we're only working in 2 dimensions. And other than that, the only thing we really need to do is we need to put all of this in its own matrix so we don't end up screwing up the primary matrix. So I'll do gl push matrix here. I'll do 2 curly braces, even though they are not needed, and semicolon. Not quite sure why that's over that way, but I'll just move them over with Alt Shift and arrow key and tap it over. And again, these curly braces aren't necessary, but I think it makes it look nicer. And at the end, I'm going to put gl pop matrix to return us to the primary model view matrix. And that should complete the render method for our game objects. And really, this should be everything for the GameObject class. We should be pretty much done with this now. The next thing I want to do is I want to create the physics system. And don't worry, it's not going to be as intimidating as it sounds. It's going to actually be really simple. So I'm going to right-click on my engine package. I'm going to create a new Java class called physics. Just click Finish. And this will only have one method in it. It'll be a public method, it'll be static, and it'll be a boolean. I'm going to call it check collision. And it'll take 2 game objects as parameters. And the way this is going to work is it's going to return true if the 2 objects are colliding, and it's going to return false if they're not colliding. And for now I'm just going to return false. because we'll need to do a couple of things before we can actually implement this method. First off, actually takes place in the Sprite class, but I'll go to the GameObject class so I can sort of say why that is. In our physics class, we're taking two GameObjects parameters, and in order to calculate if they're colliding, we'll need to create a rectangle. So for a rectangle, we need a position and a width and a height. Now our GameObject, which is the only information we have, does not have any information about its width and its height. It only has a sprite. So we're going to have to get the width and the height from the Sprite class. So I'm going to go to my Sprite class, and I'm going to create a public float method called getSX. That's going to return SX. And a public float called getSY, and that'll return SY. And I'm also going to create a public void called setSX, which is going to take a float, and just going to set this.sx SX. And the reason I'm doing this is because I think it might be interesting at some point to dynamically change the size of a sprite in game. So I'm just going to add these in so that we can do that. And this.sy equals sy. And now, in our GameObject, we can now create methods that will give us access to the size of the object. So I'll just create a getter for sx, so public float get sx, and even though we don't have our sx variable, I'm just going to return my sprites sx, so sprite.getS. I'm just going to return sprite.getSX, and a public float getSy, which will return our sprite.getSy. And that should be everything we need to perform the physics calculation. So, the way we're going to do this is we're going to create a rectangle. I'm going to call R1. I'm going to do Control-Shift-I to import it. And the java.awt.rectangle is the one we want. So now I'm going to initialize my rectangle R1. I'm going to set it equal to a new rectangle. And this takes in a position and width and height. So for my x, it's going to be go1.getx. And then for the size in x, the width will be go1.getSX. And then for my position in y, it will be .getY. And go1.getSy for my size in y. And that should not be giving me an error. Because I need to cast these to integers. So I'll just put integer in parentheses in front of every one of these parameters, and that will cast everything to an integer. And this will make this calculation a little bit less precise, but we don't really need that much precision with this. It should be good enough as it is. So now we've got a rectangle representing our first GameObject. And we'll need a rectangle representing our second GameObject, so I'm going to copy and paste that line and change it to rectangle R2. And in here, I'm just going to change everything that's Go1 to Go2. And now that we have that, we can perform the calculation to determine if they are colliding with one another. The way we're going to do this is instead of returning false, we will return if R1 dot intersects R2. And this is pretty much the exact same physics calculation that we did for the Pong game, but it's going to work just as well here. And a cool thing about this is once we add in animation, this will take into the account the fact that things can change size when they're animated. So I think it's kind of cool that we can animate the graphic and we'll also animate the physics boundaries along with it automatically. So that's a sort of neat benefit that we get from doing our calculation this way. And that should complete physics for us. In fact, that's pretty much going to complete everything I want to do with the engine for now. I can guarantee you I'm going to go back here and add more things later on, but this should be everything we need to get most of the game up and running, and we can add in specific features as they're needed. Because it's really hard to tell what features, other than what we've already added, that we're going to need later on. So I'm just going to leave it as it is right now. So let's go ahead and start the game, actually. So I'm going to right-click on Source Packages and create a new package. for com.base.game, and this will just keep separate what's our game and what's our game engine. I think that's a little bit nice. And in here, I'm actually just going to drag the game class into here and click refactor. And now our game class has been moved into com.base.game. So now that we have that, I'm going to create another package. So I'm going to create a file, new Java package, and it's going to be com.base.game.GameObject. Actually, I'm just going to be .GameObject. And this package will contain every game object in our game. And this is just really to stay organized. So I'm going to right click on this package, create a new class. I'm going to call it player. Because I've been debating on whether I should add some sort of prefix to it so that I know it's a game object, but I really don't think it matters that much in this case, so I'm just going to call it player. I've got a player, and now we can go ahead and implement the player class. So first thing we need to do, since it is a game object, we need to extend game object, and we need to import it, so Control-Shift-I, and that will import it from the engine. So now that we are importing the game object, we can start creating the player class. So I'm going to start off with constructor. So it'll just be a public player, and what do I want to take in? I'm going to take in a position, and I think that's about everything. So I'm just going to take in a position. So the first thing I'm going to do now is I'm going to set my this.x equal to x and this.y equal to y, and that will assign the position in our game object to the position we're passing in. And I'm getting an error here, and the reason is because I made all my variables in my game object class private when I meant to make them protected. So I'm going to change them all to protected and not delete the y variable. That's bad. And that should get rid of my errors, and it does. So there's one more thing we need to do before we can finish our constructor, and that is we need to create a sprite. So in order to do this, what I'm going to do is I'm going to, first off, I'm going to create a new sprite. So I'm going to create a sprite temp, and it'll be a new sprite. And sprite takes 5 parameters, a red value, a green value, and a blue value, as well as an SX and an SY. So first off, I have to decide what color I want the player to be. I want my player to be green. So I'm going to set the values to 0.25F, 1F, and 0.25F. That should make it... Actually, I'm going to set the final green value to 0.5F, and my red value to 0.1F. And that should give me an interesting shade of green. That's probably a little bit too much blue, so I'll change that to 0.25F. And we'll just see how that looks. So it should be mostly green with a little bit of blue and a little bit of red mixed in. Should give us an interesting green color. And now I need a size in X and a size in Y. And that'll be, well, I kind of want to create constants for this, because it's going to be used a lot. So I'm going to create a constant. It's going to be public static final int. I'm just going to call it size, and it will be equal to 32. This way the player is 32. So in my constructor for my sprite, I'm going to pass in size comma size. And that should... Oh, if I have to import sprite. So just going to Control-Shift-I, that will get me access to sprite. And I'm still getting an error. No arguments can be applied to float, float, int, int. Do I have to explicitly cast these to floats? Yeah, I'm going to just try changing this to final float. Does not get rid of the error. Okay, so we have an error. Come to base public void sprite. Okay, this is somewhat interesting. I think NetBeans is being stupid and not picking up on the fact that my constructor is right here. Oh, I see why. In my sprite class, I put public void sprite rather than just public sprite. Yeah, you don't want to do that. I'm going to actually go back and check and make sure I haven't done that anywhere else. I don't think I did, but it's worth double checking. And okay, I didn't. So there, now our constructor is working properly. And that means that we now have a sprite. And in fact, instead of assigning it to a variable, I'm just going to directly assign this.spr equals new sprite. And there. That should be just about everything that we need to construct the player. There is one more thing I want to do, however. And that is, since this sort of style of constructor is pretty much going to be used for everything in our entire game, I'm going to extract this into a method in our GameObject class. So I'm going to create a private method. Actually, I'm just going to put this below all the public methods just to stay organized. So it'll be a private method. It's going to return void. I'm just going to call it init. And it's going to take in 7 parameters. It's going to take in an x value, a y value, a red value, a green value, a blue value, and it's going to take in a size in x and a size in y. So this is taking in a lot of parameters. And what it's going to do is essentially exactly the same thing as this is doing. So this dot x is equal to x, this dot y is equal to y, and this dot spr equals new spr. Excuse me, new sprite. Taking in red, green, blue, excuse me, red, green, and blue, sx and sy as the parameters. And this will just provide us a really easy way to initialize every object in our game. And I'm going to sort of convert this to use the init method using x and y, 0.1f, 1f, 0.25f, and size, and size. And that should... Oh. And of course, I again forgot that it needs to be protected since we're trying to inherit it. So, we have a protected init method, which now we can use in our player class. And that, in fact, we can use in every class that inherits from GameObject. And it'll just make it a lot easier to initialize all of our game objects like this. So next thing we're going to do is we're going to set up player mechanics. Now, this is all going to be done in the getInput method, so I'm just going to create a public void getInput. And this time I will be doing all the input methods for the player in the player class. And the only thing here is we have to actually call it. So I'm going to go to game, I'm going to go to my getInput method, and I'm just going to... Actually, I did never even set this class up, so let's go ahead and do that. So I'm going to create a constructor, public game. It won't take anything in. I'll just be blank for a moment. And what I'm going to do is I'm going to keep track of a list of game objects. And we're actually going to change this later, but it won't be that drastic. And really, I'm just going to... I'll explain that when we get to it, but this will be temporary. I'm going to create a private array list of game objects. And I'm going to import array list. And... Oh, okay. Oh. This will be called objects. And this will just be like that. And in my constructor, I'll set objects to a new array list of game object. And I can't type for some reason. Oh well. And I spelled object wrong. Well done. Okay. And now that we have all that done, I can go ahead and implement my basic update and render methods. So for each game object, geo, in objects, I'm going to go to geo.update. And for each game object, geo, in objects, I'm going to go geo.render. And this right here will completely finish our update and render methods for the game class. The only thing we have left is getInput, which we're going to implement in just a second. But first I'm going to create another variable. It'll be a private player. I'm going to call it just player. I'm going to Control-Shift-I to import player. And it's correctly found our player class. And in our game constructor, first thing I'm going to do is I'm going to go to my objects list. I'm just going to add player. And above that, I'm going to initialize player. So player is a new player. It'll be at position... where should I put it for now? For now, I'm just going to put it at display.getWidth divided by 2 minus player.size divided by 2. That should put it at the center of the screen in X, which I explained in my Pong series. And display.getHeight divided by 2 minus player.size divided by 2. And that should put it at the exact center of the screen. But, oh. In Control-Shift-I, no. Alt-Enter, create, oh. It's because right here with getHeight I forgot to put 2 parentheses. It's okay, those mistakes happen. And that should pretty much create a player. So the only thing I have left to do in this game class is under getInput, just call the getInput method. So do player.getInput. And I believe that should be everything for the game class. So now we can go back to the player class and actually implement this getInput method. So the way I'm going to do this is the exact same way that we did it in the Pong series. If keyboard.isKeyDown. So we're testing if some key is currently being pressed. We're going to test keyboard.keyW. So if we're pressing the W key, then what do I want to do? Well, I just want to move, and I'm going to, just like in Pong, I'm going to take in some direction. So this is X and this is Y. I want to move up, so I'm going to pass in a 1 for Y. And we'll create this move method in a second. And now, we'll just do the same thing for other keys. So if keyboard.isKeyDown, keyboard.keys. So if we're trying to press the down key, we, again, don't want to move on the x-axis, we want to move on the y-axis, and we want to move down. So that will be -1. And now if keyboard.isKeyDown, keyboard.key so that would be left, so we want to move 1, is that right? No, -1, comma 0. And if our keyboard.isKeyDown, keyboard.keyD, we're just going to move 1, comma 0. And that should be all the input we need for now. For now, we just want the player to move around. So, now that we have, in theory, everything required to make the player move, I'm going to implement the move method. It's going to just be a private void method called move, which takes in 2 parameters, int, why not, float mag x, and float mag y. And mag is short for magnitude. So I'm going to have a constant for my players. Actually, no, I'm not going to have a constant. I'm going to have a variable. I'm going to have a private float speed. Actually, I'm going to do this really strangely. And it's not going to be easy to explain why I'm going to do it like this just yet, but once I start implementing levels, this will probably make a little bit more sense to you. So, I'm going to actually create a public method. It's going to be public float called getSpeed. And the reason I'm going to do it with a method is because I'm not going to store any one variable for my speed. I'm going to always calculate my speed. And the reason I'm going to be calculating my speed rather than storing it in a variable is because that way it makes it really easy to change the speed. And I could have, in theory I could set it up so I just have these 5 or 6 factors, and just changing them can drastically increase or decrease my player's performance in a huge variety of areas. And I think that's kind of a cool feature. So, And again, it's really not the easiest thing to see why this would be useful just now, but yeah. So for now, I am just going to return a number. And for now, I'm just going to return 4. And we'll see how that works. So, and later on we'll replace this with some algorithm that will calculate how fast we should be moving, depending on whatever factors we want to control that. And you know, just gives us an easy way to make speed controllable. So now that we have a method to get speed, we can implement the move method. So, if we call the move method, we want our x to increase by our speed, so get speed, multiplied by whatever magnitude we passed in. And we want our y to increase by whatever our speed is, times our magnitude in y. And if all goes well, then this should be allowing us to move a player, which should be mostly green, around the screen. So let's go ahead and test it. So if I go ahead and hit the run button, I get a completely black window with a green square in the center. So that's good. That's at least part of what I want. Now if I hit W, A, S, and D on my keyboard, if I hit W, I'm moving up and down. And I'm doing W and D, S, excuse me. So I can move up and down. If I hit A and D, I'm moving left and right. So I have a completely controllable player. I can hit 2 keys at once to move diagonally. If I try hitting 2 buttons to go in 2 different directions, it cancels itself out, which is also good. So this is a lot of what I want pretty much already done. So I think player movement pretty much covered for now. And since I have time left, I'm going to go ahead and implement leveling. So I'm going to go up here, and I'm actually debating whether or not I want to do calculated levels or not. And I'm just actually going to have level as a variable for now. And if we want, we can go back and change it to calculated levels. But just so that I can make it easy to do that later, I'm going to create a getter for get level. And I'm just going to return my level variable. So I'm going to create a private float level. And at my initialization, I'm going to initialize my player's level to 1. And right now, we're going to use our getter right here everywhere we want to actually use the level, other than our constructor. And this way, if we ever actually want to change this to be some algorithm, all we have to do is go in here and retype it to whatever our algorithm is supposed to be, and it won't have to worry about going to everywhere I wrote level and replacing it with get level. So it's just convenience, really. So I have my get level method, and now I can go ahead and start implementing leveling. So first off, now that I have my level, I'm going to get experience. So I'm going to create a private float, XP. I'm not really sure what how much XP I want per level yet, but there's probably going to be some algorithm for that. And in fact, I'm pretty much immediately going to change this get level method. Instead of returning level, return my level calculated for my experience. So already I am preparing to delete this level variable. So now that we have all that done, we need to create some methods for this. So I'm going to create public void add XP, since XP is private, and it'll just be int amount. Actually, I'm going to change XP to an integer because I'm not. I know why not. I can have decimal amounts of XP. Why not? I'll just be float amount, and I'll do XP plus equals amount. And if we want to take XP, we can actually pass in a negative value into here, and there you go. So this works both ways. And I'll eventually have to test for leveling up. That shouldn't be that bad, though. So, yeah. Now that we have the basic sort of leveling system all ready to go, more or less, all I really need to do is I need to make things relative to my level. So I need to figure out what I really want to be relative to my level. And right now, all I'm going to do is just health, because that's the first thing that comes to mind. You want your maximum health to be based on level. I'm going to do this with a getter, so public float get. I'm debating on whether I want my maximum health to be a float, so I'm actually going to make it an integer. So public int get max health, and there I have a get max health method. And now I have to figure out some algorithm based on level to calculate a max health. And right now I'm just going to return level times 10. And I'm probably going to change that later. And almost forgot. Return get level times 10. There we go. So I'm going to return whatever my level is multiplied by 10. And I'm going to actually have to cast this to an integer, because in theory my level could be a floating point value. Even though that makes so little sense that I'm actually going to fix that right now and change my level to be an integer. So we have a basic method for getting max health. Every time we I'm sorry, I'm having a bit of a brain fart here. Every time we level up, we will gain 10 extra health. So at level 1, we'll have 10 health. At level 2, we'll have 20. At level 100, we'll have 1,000. So, and, yeah. So, now we have maximum health, we'll need regular health. And I'm pretty sure I'm going to need a variable to keep track of this. So I'm going to have a private int. Yeah, int. I'm debating on whether I want this to be a floating point value again. Do I want the player to be able to have a decimal amount of health? Well, no, I don't. It's private int health, and in my constructor, for I'm going to initialize health to 10, and I'm going to have a method down here, public int get current health. And I'm actually not just going to straight return my health. Well, I am going to return my health, but I'm going to do something before that. That is, if my health is greater than my maximum health, then health is equal to... Actually, I'm going to store it to a variable. So int max equals get max health. And if my health is above my max, then my health is equal to my max. And that way, my health will never, ever exceed my maximum value. And if I, for some reason, want my health to go over my maximum value, then I could, in theory, change that here. So I have my health set up. It's based on level. If I level up, my health will increase. And, yeah. So a couple other things I think might be based on level are my power, my strength, how hard I hit enemies with swords, because it makes sense I'd want my damage to increase with however much I level up. I'm not necessarily going to use swords, I could use anything, but I mean, I'm just going to assume for the time being that we are, so yeah. So I'm going to create a public int called getStrength, and this will return my level times 4. And all these sort of algorithms for calculating max health and strength and stuff, they're all temporary. I am going to change these later. Almost guarantee it. But, for the time being, I'm just going to leave it like this. Actually, I think 4 is a little bit much. I'm going to make this actually a floating point value. I'm going to return level times 1.25. Because I don't want the player to hit too hard at level 1. 4 points of damage seems like... Actually, you know, I'm going to make it 4, just because I can change it later. I'm going to change it later, so why not? And the other thing I might want to have affected by level I can think of right off the top of my head that I'm probably going to have in my RPG is some sort of magical ability. So I'm going to create a public, and it's going to return a float called get magic. I'm just going to return level times... No, I'll just do 4 again. And these are going to change, but I'm just putting them in so that I know that at some point I'm going to have some method for getting my strength and getting magic. And you know what? Later on I might even choose to remove these and do something different. I don't really know, but I'm putting them in for now. And I, once again, have failed because I want get level. Not just straight level. That's not what I want. And that actually might be everything for this video. I'm not sure what else I want to do. But first off, I'm going to go through and make sure that I'm not doing the get level mistakes anywhere else. Okay. But actually, because I'm going to do it eventually, I am going to delete the level variable completely. And this way, I just know from the start that I'm not going to need this level variable, and they'll force me to not use it anymore. I'm going to implement a temporary leveling algorithm, which again will be changed. So it's going to return my experience times... Actually, I'm going to return experience divided by... And this is where I'm going to put in however much experience I want per level. For now, I'm just going to do 50, which is again subject to change. And I'll do all this plus 1 so that we start at level 1 instead of level 0. And that really should be everything. I think I have to cast this to an integer. Yes, I do. Okay, good. That should be just about everything for this video. Except, you know, let's go ahead and add in a method to test this. So, I'm going to create public void update, and create an update method, and add @override, because NetBeans will hate you forever if you do not put this above every overridden method in your entire Java project. So, in my update method, I'm just going to do system.out.println, and I'm going to print out all these lovely variable sets that I've created, which aren't technically variables, but you know, they're information about our character that we can calculate. So yeah. So I'm going to just return get stats, I don't know, plus, and I'll do speed plus get speed plus level. Actually, level would probably come first, shouldn't it? Oh well, it doesn't matter. Level plus get level plus max HP plus get max health plus HP plus get current health. And what else do we have? Strength and magic? Okay. Why not? Strength plus get strength and magic. Almost forgot the space there. Magic plus get magic. And that should, in theory, just display my stats every single frame. So, if I run, I'm now having my player's stats just absolutely spammed in the console window. But it does mean that everything that I've done so far is working. I have a speed, a health, a strength, and magic. And if I increase my level, say... Actually, if I initialize my XP to something like 150, which should put me at level 3, then everything... Oh, it puts me at level 4, actually. You'll notice everything adjusts accordingly. Which is exactly what I want, at least for the time being. So yeah. So thank you, I hope you enjoyed. And in the next video, we will be continuing this, and hopefully it'll be starting to add in some actual gameplay to this, other than just a list of statistics. So thank you, and